2.4 is the average rate of change. Rate of change of function.
Professor, can you send the attendance again, please?
Yeah, sure.
Thank you.
Average rate of change of a function. I don't understand the net change, the formula, but how will we? Yeah, I will go over the net change again, and I will give another example. Okay. So you have to know one thing. The net change formula, the net change of a function f of x between 2 points, between the first point x equal a and the second point x equal b, is given by as net given as f of b minus f of a. So the net change, this is the formula, is given as f of b minus f of a. Okay. So this is the first formula. It's called net of change of the function between 2 points. Second formula is called the average rate of change. The average rate of change of the function above, the function, of the function, this function f of x, that change between x equal a and x equal b. Okay. So the function above is given as the net change, the average rate of average rate of change equal the net change over b minus a, or in other word, equal the net change, I know, f of b minus f of a, f of b minus f of a over b minus a. This is the average rate of change. So the formula for the average rate of change is equal net of change over b minus a. The net of change is given as b, as this formula, b of f of b minus f of a. So I plug net of change f of b minus f of a over b of minus a. Is the formula clear here? So this is the average rate of change. Now, let me give you an example. So, before I give you the example, in general, the net of change is the secant, is like the slope of the secant line between the points on the graph. It's close to the secant line, slope of the secant line, that passing the 2 point on the graph. So the example now, let's f of x equal 3x minus 5. So the question is now find the average rate of change between 1, x equal 0, and x equal 1. Number 2, x equal 3, comma, x equal 7. Number 3, x equal a, and x equal a plus h. We'll do the first one. Average rate of change equal f of b minus f of a over b minus a. What is b? What is a here?
1 is b and 0 is a.
This is b, this is a. So let me give you more information. If I want to use this as my b and this is my a, I have to plug my b inside the formula and a inside the formula. If I want to use this as my b and this is my a, I have to plug by the order b and a inside the formula. So wherever I want to choose a, it's fine, it's work normal. But I have you have to know what is my a and plug inside the formula, and what is my b, I can plug inside the formula. So let me do this as this is my a and this is my b, and in the second time I will do this as my a and this is my b, and I will show you they give me the same answer wherever, but I have to make sure I use the order. Okay, let me make this is my a and this is my b. So now let me plug inside the formula f of b. This is b. So here let me explain more. So my a is 0 and my b is 1. I plug inside the formula f of 1, this is b, minus f of a, f of 0, over b minus a is 1 minus 0. F of 1 plugged inside the function is 3 times 1
-2.
minus, it's -2. Okay, we'll see. F of 1 you plug inside the formula, it's 3 times 1 minus 5 minus, you plug the 0 inside the equation here, inside the function, sorry. I get 3 times 0 minus 5 over 1 minus 0 is 1. And anything over 1 is can cancel, you can remove it. It will be like only the numerator. So 3 times 1 is 3, minus 5 is -2, minus 3 times 0 is 0, minus 5 is minus 5, minus over 1. So the same thing is over 1 equal -2, minus times minus is positive, plus 5, over 1 we can remove the 1, minus 2 plus 5 is 3. This is the answer. Angel is 3. Okay. Now, if I want to use in different way, here I use A is 0 and B is 1. If I want to flip, so I will show you in different way. Here, if my A is 1 and my B is 0, they give me the same answer exactly. So the same things, average rate of change equal f of B minus f of A over B minus A. So f of B is 0, f of 0. F of A is f of 1 over 0 minus 1 is minus 1. Now, f of 0, I plug it here, f of 0, they give me minus 5. F of 0 is minus 5. Plug the 0 inside the function here, they give me equal, show you again, f of 0 is 3 times 0 minus 5 minus f of 1, you plug the 1 inside the function, so I get 3 times 1 minus 5 over minus 1. So now 3 times 0 is 0, minus 5 is minus 5, minus 3 times 1 is 3, minus 5 is minus 2, over minus 1. And this is equal minus 5, minus minus is positive 2, over minus 1. Now minus 5 plus 2 is minus 3, over minus 1. Minus 3 over minus 1 is 3. So the answer is 3 here, and the answer here is 3. Wherever you want to use A or B, they will work the same answer. But you have to plug it by the order here. F of B is 0, f of 0, f of A is f of 1. So the first answer is 3. So the first one here, they give me 3. Let's do the second one. Second one. X equal 3, comma, x equal 7 for the function f of x equal 3x minus 5. Who will do this one? Who will do this one? Who will do this one?
So do you just want the final equation?
Yeah. What is A here, first of all?
So for me, I chose A as a 3 and B as 7.
For, again, you use x equal 3 as A?
Yeah.
Okay, this is A, he said. And this is B, right?
Yeah.
Okay. Now, plug inside the formula. F of B minus f of A over B minus A.
It would be 16
16
Minus 4.
minus 4, yeah.
minus 4.
7 minus 3.
7 minus 3 is, okay. What do you give me?
You would
16.
get 12 over 4, which would be 3.
Okay. So let me here do the steps here. F of B is f of 7 minus f of A is 3 over 7 minus 3. You plug the 7 inside the function, they give him 16 minus 4 over 7 minus 3, they give you 3. So look, here we'll get another, the average rate of change is 3, the same like this first one. So x equals 0 and x equal 1, the average rate of change is 3. And for x equal 3 and x equal 7, the average rate of change is 3 again. Let's do the third one, between a and a plus h. Who will do this?
We start with, what is it, 3 times parentheses a plus h minus 5.
So what's your a and what's your b?
Sorry,
First
I
of
did
all,
a is a and b is a plus h.
this is b,
Mhm.
and this is a, right?
Yep.
Okay. So now, average rate of change, he said f of b minus f of a over b minus a. What to get, f of b?
So f of b is 3 parentheses a plus h minus 5.
Okay, nice. So like 3, you plug this inside this.
Yeah.
A plus h minus 5. Okay.
Mhm.
Minus what?
Minus 3 times a minus 5.
3 times a minus 5.
Divided by a
B
plus
minus
h minus a.
b minus a, right?
Mhm.
Okay. Now after you plug this, well what's
Mhm.
simplifying?
Yeah.
3. Okay, let's simplifying.
Yeah, so we get 3a plus 3h
3a plus 3h
minus 5.
minus 5
Parentheses
And-
minus 3a minus 5.
minus 3a
Yeah.
minus plus 5
Plus 5, excuse me. Yeah.
over b minus a.
So on top, we just end up with 3h because everything cancels out.
Yeah, this cancel this one. Okay.
I got you.
And 3a with this one cancel each other. Here b minus a, let me hold on. So here b minus a, b minus a, b minus a. So my b here, my b is a minus a plus h minus
Let's say
a. I get here h, here h. So I get here 3h over h. And the final answer is
3.
3. So look, the average rate of change, 3, 3, 3. So why always 3 for this example? Why it doesn't change?
Because that's the slope of the line we're graphing.
Exactly. So the function, if I give you a function is a line, if the function is a line, so always the average rate of change will be constant. Doesn't change for any two numbers. Because here my function f of x equals 3x minus 5, it's look like a line. It's a line already. The 3 is a slope. The slope here is the 3. Y-intercept is minus 5. So this is a line function. So for any line function, the average rate of change always constant. Doesn't change for any two numbers. So here I can set linear function, have functions, have constant rate of change. Rate of change is fixed for linear function. will not change for any two numbers. So that's why they give me 3, 3, and 3 again. Okay, any question? Okay. So now let's go over 2.6, transformation of function. Two point six transformation. Of functions. So first things, we're going over vertical and horizontal shifting. By the way, before we start this section, let me show you the graph of some simple functions. So we'll graph some simple functions. So here. Okay, so we have to know some graphs for some function, and this graph for this function will be default for our work during this section. Okay. Here. So the first function we have to know is the x square. The graph for function f of x equal x square. It will be like a parabola, look like this. This is the graph of f of x equal x square, parabola. Second function is f of x equal x to the 3. F of x equal x cubed. It will look like this. Okay. So when I told you f of x equal x square, you have to know the graph for this function look like this, parabola. F of x equal x cubed look like this. Third one, the function f of x equal square root of x, or the radical of x. F of x equals square root of x. Square root of x. Third function is f of x equal here f of x equal the third root of x. We look like this. Number 5, the graph of f of x equal 1 over x. So the graph for this function is like this. Something like that. The graph of 1 over x squared f of x equal 1 over x squared. It has to be something like that. And the last one, the function f of x equal the absolute value for x. F of x equal the absolute value for x. The graph for this function look like this. Okay, so this is will be, you have to know the graph of these functions. This function will be like a default. We'll use it during this class. Of x equal x squared, f of x equal x cubed, square root of x, the cube root of x, 1 over x, 1 over x squared, the absolute value for x. Okay. Now, first things, we have to know the vertical and horizontal shifting. The vertical and horizontal shifting. So I will give you the definition first of all. Then I will explain this definition. Okay. So the definition says here. If I have a constant number c, this c is positive number. The graph for any function y equal f of x plus c, we shift a graph y equal f of x upward c units. Okay. And the same things, if this constant, we subtract the function from this constant, the positive number, the graph of this function is by shifting the original graph downward c units. So this is mean upward, downward, vertical shifting. Now for the horizontal shifting, let me give you the definition. Here. Same things, same idea. To graph the y equal f of c, f of x plus c, we shift the graph of y equal f of x to the right c unit.
No, it's the opposite. It's the opposite. Plus move to the left and negative move to the right.
For plus, okay,
Plus
yeah,
to the left and negative to the right.
nice, thanks. Your left. Hold on. Change the sign. Negative, positive. Thank you.
You're welcome.
So the graph of the function f of x minus c, look, the c it's inside, not like here. The c here is outside the function. Let me start from the beginning. If I have a positive number, any positive constant number, and this number I want to add it to the function, the original function, my original function y equal f of x. If I add this number to the function, I get y equal f of x plus c. The graph of this function is by graphing the original one, and we shift the original one upward c unit. This is for the first one. For the second one, if I want to subtract this number from the function, from original function, so the graph for this one of x minus c, look, the c is outside the function, is by graphing the function f of x, the original one, and we shift this function downward c units. This is me in the minus here. Now, for the horizontal shifting, if I want to subtract this number, this is a positive number, from the function, but from inside. So this is me in the graph of this function. I have to shift the original function to the right c unit. If I want to add this number, but it's inside the parentheses of the function, I have to shift the original function of y equal f of x to the left c units. Any question for the definition? Makes sense? So this is for up, down, vertical. Here, vertical shifting. Vertical. Shifting. Here, horizontal. Shifting. Right, left. Upward, downward. Okay, let me graph the function and I show you by the graph how we can do shifting vertical and horizontal. So this is my Cartesian plane, the x and y axis, and this is for the second horizontal shifting here. So this is for vertical shifting, this is for the horizontal one. Okay, suppose my graph should look like this. Here by y-axis. Here's the x-axis, y-axis, x-axis. Suppose my graph look like this. it's not graph of a function like this. It's not nice. Like this. This is my f of x, the original function. So if I add c unit to this function, this means I can graph f of x plus c by shifting the original one upward c unit. So for example, I have to shift this one c unit. I have to go up c unit, 3 unit, and here the same thing, c unit. So my new function, my new graph, it's look like this. Here c unit. Look like this. Goes down, goes like this. So this is the function f of x plus c. Now, if I want to subtract from this function any number, but it must be a positive number, this means I have to shift the original function c unit to the down. So for example here, I have to shift it c unit to the down. So my function look like this, like that, going down like this. So this is f of x minus c. So you have to understand the first one. What is the mean of shifting upward and shifting downward? So here vertical shifting. Makes sense? Okay, for the second one, the horizontal shifting now. Again, the same idea. If my function look like this, same things like that, going down, going like this. This is my function, the original function, f of x. Now I want to add c number inside the function. So when I add c to inside the function, I have to shift the original one to the left c unit. So here, for example, I want to add element to this function will be shifted to the left c unit like this. So here the graph will be like this. So this is the graph for f of x minus plus c unit for everything. We close more. Okay, so now if I want to shift it, this graph to the right, so I have to subtract the c from the function, the original function. move it to the right, like this. C unit. So the original function will look like this. Something like that. Something like this. And this is f of x minus c. Any questions so far? Any question for the horizontal and vertical shifting? Okay, let me give you example. By using graph of x equal x square, graph each of number 1 g of x equal x square plus 2, number 2 s of x equal x square minus 1, 3 of x equal x plus 2 square, 4 L of x equal x minus 1 square. Who will do the first one? Or give me like the idea how is shifting. First of all, the graph of the function f of x equals x square. It's from the first slide here. This is the graph of the function f of x equal x square. We're going to use this graph, number 1. Okay. Who will do the first one?
So we shift -1 down.
The function x square plus 2. What does that mean? How it's shifting?
Vertically.
Up or down?
Up.
Up how many units?
2.
2 units. Nice. So this is the graph of the function x square. This is the original function. So this is the function f of x equal x square. This is the original one. Now the question asks me to graph g of x by using the function x square. So g of x equal x square plus 2. The 2 is outside the function. It's not inside like number 3. It's outside the function. This means by using the rules here, if the number is outside the function, we have to shift the graph of y equal f of x upward c units. This means we have to shift the original function of x equal x square 2 units to the up, plus 2 units to the up. So 2 units to the up. Suppose this, for example, this is 2 units here. Okay. This is 2 units here. So the new graph, it's look like something like that. This is f of x equal x squared plus 2. Any question for the first one? It's clear? So the graph of f of x equal x squared, this one. The graph of the second one, this one. F of x equal x squared plus 2. Shifting the original one 2 units to the up. For the second one, who will do the second one? Second part of the example. Here, number 2, s of x. Who will do the second one? Or tell me how is shifting the f of x equal x squared, the original one. Where we have to shift the original function?
1 down.
Down. How many unit?
1.
1. Yes. So we shift this, the original function x squared minus 1. This means we have to shift the original function 1 unit to the down. Here, the graph of this function of x minus c is shifting the graph of y equal f of x downward c unit. This means here I have to shift this function, the original one, downward 1 unit. So again, the graph of the original function like this. This parabola. Now, this is f of x equal x squared, the original one. S of x is x squared minus 1. This means we have to graph the function x squared, then we have to shift it 1 unit to the down. So the 1 unit to the down be like this. This 1 unit to the downward. So the graph is gonna be look like this. So this is second function here. It's s of x equal x squared minus 1. Here, by the way, is not f of x. Here, g of x. G of x, first function. Any question for the first one and the second graph? Okay, no questions. So clear, everything clear, right? Yep, thanks. If you have any question, you can ask. Don't feel shy. You can ask. Now, for the third one, who will do the third one? Number 3. D of x equal x plus 2 square, everything square. Look, the number, it's inside the function, and everything now square. But the first one is x squared plus 2. Outside, the number is outside the original function, x squared. Here, the number, it's inside the function, x plus 2, everything square. So how we shift it, vertical or horizontally for number 3? And how many units? And to which side, left or right side, or up or down side? Horizontally. Yes, this is true. How many units? 2 units to the left. This is right. Go back to the definition. Here, f of x, d of x equal x plus 2 square. A plus for this one, the graph, to graph the function y equal f of x plus 2, we shift the original function y equal f of x to the left c unit and is horizontally shifting. So number 3, we shifted horizontally 2 units to the left. Three, d of x equal here is the graph, the Cartesian plane. And this is my original function here. It's x square of x equal x square. Now x minus plus 2, we shift this original one to the left 2 units. So we have to shift this one to unit to the left. So the graph will look like this. So this is d of x equal x plus 2 square. Okay, so this is the function. We shift the original function to the left 2 units. Okay, for number 4, who will do the last one? Here, L of x.
We shift the whole graph to the right one.
The red one. The red ones look like this. No, we don't have to to graph, like you don't have to graph for every time, like in Weber sign questions, you don't have to graph the original function. But because I want to show you how is the original function, we shift it. So the answer for the first one here is this graph. For the second one is the blue one. For the third one is the blue one. But because I want to show you how we shift, we draw the original one, then we shift. For number 4, how we shifted this one? Vertical, horizontally, and how many units?
It goes horizontally to the right 1 unit.
1 unit, perfect. So again, the same idea like here. To graph this function, we shift the original function to the right c unit. Okay. So number 4. It is L of x. L of x equal so L of x equal x minus 1 squared, x minus 1 squared. So again, show the original one. The function, the original function is this one. This is x squared f of x equal x squared. We shift 1 unit to the right. So here is 1 unit. Unit. Now the graph will be look like this. So this is L of x. Everything's square. Okay. Anyone has a question? Okay. So no questions. Another example. Example. Sketch the graph of f of x equal square root of x minus 3 plus 4. I will do this function.
May I try?
Yes.
We go up 4. No, yeah, we go up 4 and
Okay,
to the
hold
right
on. Hold on. What is the original function?
0,
No, what's the,
1,
no,
4,
hold on, Angel.
4.
My question is, what's the original function? How we can start? Which function from the fourth here we have to use from the 8 functions? 1, 2, 3, 4, 5, 6, 7. The 7 functions.
The third, the
Third
yellow.
one. Okay, nice. So the like you have to say the original function here of x equal square root of x. So now what I have to do shifting? What I have to do?
We will move up 4 units and 3 units to the right.
You have to move up. No, you have
Up
to,
4 and 3 units to the right.
okay, but in general, just start from here. If you want like the correct things, you have to start from this function. And like
Right.
from this first. So what we supposed to do here?
Move 3 units to the left, right.
Nice. Then
Up 4 unit.
perfect. Thank you so much. This is true. So my original function is the square root of x. This is the first step. Second step, we have to shift it inside the function. Square root of x minus 3, the minus 3, it's inside the function. And if it's inside, we have to shift horizontally, right or left. Because minus 3, so we have to shift it to the right 3 units. We finish from this step. Now we go to this step. Plus 4, this is mean we have to shift it 4 units to the up. It's clear? So my original function O of x is equal square root of x. So I know the graph of this function. The graph is like the yellow one in the back. This is O of x equals square root of x. Now we shifted 3 units to the right. 3 units to the right. Here's 1, 2, 3. So it will be look like this. This is the square root of x minus 3. Then we shifted 4 units to the up. So now up 4 units. So 1, 2, 3, 4. So this is f of x equals square root of x minus 3 plus 4. This point here is 3, 4. This point here is 3 and 0. This point here is 0 and 0. Any question? Oh, I cannot move it. Okay. Any questions so far? How to graph the function look like this? Okay. Now, after we learn how to shift right and up and down, left and right, so now we're going to do the reflecting graph. Reflecting graphs. The definition is, again, so the definition is here. Let c is greater than 0, positive number. To graph the function look like this, y equal minus times f of x, we reflect the original function around the x-axis. But if the minus is inside the function, we reflect the graph of y equal f of x, the original one, around the y-axis. Okay, what does that mean? Let me explain more. So this is my Cartesian plane, for example. And here is for the other function. Here's the y-axis. Here is the x-axis. Here's the x-axis, y-axis. Suppose my graph look like this. This is my original function, f of x. Now to graph the first one, reflecting around the x-axis, we have to draw a mirror. This is my mirror, put it in the x-axis. This is mirror here, okay? So put mirror down, like this. This is my mirror. Everything will be reflected around this mirror. So the new function around the x-axis, it will be like this. This is up, like that, down, something like that, going like that. Okay, so this is the function f of minus x. Here, this is my mirror around the x-axis. Clear how to do the reflection around the x-axis? Okay, here, reflection around x-axis. Now for the reflection around the y-axis, suppose my function look like this. This is my function. This is f of x. And the question is graph the function y equal f of minus x. So again, my mirror is the y-axis. This is my mirror. Everything reflects around the y-axis. This means the graph will be look like this. Like that. Going like this. This is f of minus x inside the minus. Makes sense? Be nicer like that, then moving more. No, it's not nice. Like here. F of minus x. So here, any question for this one? How to do reflection? Okay. Let me give you example. So the example is sketch the graph of each of the functions. Yes, can go back. Okay. Sketch the graph of each of the functions below. First one is f of x equal minus x squared. Number B, g of x equal square root of minus x. Oh, that's it. Who'll do the first one and tell me what's the original function for the first one?
It's a parabola flipped over the x-axis.
Parabola for the function x squared, right? So the first one here, the original function
Is f of x equals x squared.
square. The function here, the original function is x squared. Now, what does that mean? F of x equal minus x squared. This means if we multiply the minus to this function, I get minus of the original function equal minus x squared. And this is equal f of x. This means if I want to draw the function f of x, I have to draw the original function, then I have to multiply by minus from outside. A minus outside means we have to reflect the function around the x-axis because the minus it's outside. Okay, makes sense? Clear what I said?
Yes.
Okay, so the original function is x squared, then we multiply by minus from outside. After we multiply minus, we get the original function. The minus again reflected. So this is my original function here, x squared. This is this is O x for x squared. Now, drawing f of x minus x squared, this means we have to reflect this one around the x-axis. So my mirror is here. This is my mirror. So the graph will be like this. Like this. So this is f of x. And here O of x, like the original function. Any question? Any question for this one? For the second one, who will do the second one? is the second one. G of x equals square root of minus x. What is the original function here? Here I get a question. The black, hold on. The black is the reflection. No, the black is the original one. The reflection is f of x, the blue one. Hold on. Angle. So this is the reflection. This is the reflection one. Okay. The reflection is f of x equal minus x squared. Here the original function, O of x. Yes, Angel. What is the original function for g of x? I mean, like, which function of this is the original one? 1, 2, 3, 4, 5, 6, 7. 3. Yes, this is true. Of x equals square root of x. So my original function is original function. O is mean original, square root of x. Now, here we multiply the minus from inside. To make the original function look like the g of x, we multiply the minus from inside. Minus x equal, we plug the minus x inside. And now this function, original function, it's look like the g of x. So to draw the function g of x, to sketch this graph, we have to draw or sketch the original function, and we have to flip it reflected around the y-axis because the minus it's inside the parentheses. So the original function is the black one. Here, the black one. This is the original function. The reflection one is around the y-axis. So my mirror is this. Now the graph is reflecting around the y-axis, so it's going to be like that. This g of x equals square root minus x. So this is the reflection function. Any question for this one? Okay, now we have to go over the vertical stretch and shrinking of the graph. Then we go over the horizontal one. So stretching and shrinking of the graph. So I'm going to give you the definition. We have like 8 minutes left. And next time we go over the definition. Vertical, stretching, and shrinking. Of graphs. So now, here. Now, if the function is multiplied by numbers, for example, like that, to graph function like that, y equals c times f of x, we have to know, first of all, what is the value c? Is it greater than 1 or is between 0 and 1? We have to check. If it's greater than 1, the c here, if this c is greater than 1, we have to stretch the graph, the original function, vertically by the factor of c. But if this number is between 0 and 1, this means we have to shrink the graph of y equal f of x vertically by a factor of c. So let me explain more by graphing. What does that mean? Suppose I have graph look like this. This is my original function here. This is f of x. Now to graph c times f of x, and this c is greater than 1, like 2 or 3 or 4 or 5, whatever. This means we have to stretch the graph vertically by a factor c. Stretch means going to be something like that. This is mean stretch vertically. Stretch the function vertically. So this is mean here, the function g of x equals c times f of x, and here c is greater than 1. But if c is between 0 and 1, like 1/2, 1/4, this means we have to shrink the function. So shrink means something like that. This is shrink of the function. So here, for example, my function is called L of x equals c times f of x, and here c is between 0 and 1. Okay, any questions so far about this one? Anyone has a question for this one? Next time we go over it again one more time. This is y-axis here, and this is the x-axis. Okay, we'll stop until here today.